So we will be looking at the reactivity of group 1 metals. Right, to start off with, they're all called alkali metals because when they go and they react with water, they should all go and form alkalis. Right, so just to prove that, we've chucked in some universal indicator. If we get any alkalis present, it should turn a purple colour or a blue colour, etc. Right, all 3 of these are stored underneath oil, right? And we store them underneath oil because they will react with the air, right? So, first one that we're going to look at is going to be the one at the top of the group, so lithium. Right, lithium should be the least reactive. Right, lithium only has 2 shells of electrons. So because it only has 2 shells of electrons, that outer shell is relatively close to the positive nucleus. So the nucleus will hold on to that shell quite comfortably. So it's less likely that our lithium is going to go and lose the outer electron very easily. So like I've just said, when we go and we're reacting any alkali metals with water, we go and we form a hydroxide. So when we go in and we've got lithium, we're going to form lithium hydroxide and hydrogen, right? So the reaction that we should be seeing with the lithium is that our lithium is going to react with the water and we should form lithium hydroxide plus hydrogen should be given off. Right, you can tell another property of alkali metals is that they're not very dense. You can see from there that it's not very dense because it's not sinking. All it's doing is it fizzed around and reacted at the top of the water. We can tell that we've gone and produced an alkali. We can tell that we've produced lithium hydroxide because you can see that the universal indicator has changed colour. Right, so that's lithium. Right, the second one that we're going to look at is going to be sodium. So sodium is further down, which means that sodium has more shells of electrons, right? So sodium has 1 more shell of electrons. Right, when we go and we cut through sodium, right, sodium is a lot softer than lithium. So we managed to cut through the sodium a lot easier than we did the lithium. Right, so same again, sodium is kept underneath oil. So sodium should be more reactive than lithium because that outer shell of electrons should be further away from the positive nucleus, so the positive nucleus won't have as much of a hold on to it. So the reaction that we should go and get, we should have sodium plus water should go and form sodium hydroxide plus hydrogen. Right, so that's our second reaction. Right, at the same time, it's important that we only go and put in a tiny amount, right? If you go and put in too much, it goes over something, and a proper chemist would probably be able to explain this better than I can. It goes over something called critical mass, and it won't just fizz around on the top, it would explode. So if we go and drop in our sodium, so you can see there, right, the sodium fizzing around on the surface, it's heated up that much, so we've got a nice molten ball of it at the surface. So it's gone, and it's more reactive than lithium was. Right, a little trick that we can do with sodium. If we go and get a small bit of sodium, and we put some filter paper in to start off with. So we're decreasing the area that's in contact with the water. We should see something a bit more spectacular. Right, so same again. Right, this time the sodium is gone and it's ignited the hydrogen that's being given off, so it's actually set on fire. Right, if we, just because I've got a little bit more, just do that again. Is it going to do anything? Oh, there it goes.
Why doesn't it last very long?
Because there's not very much of it. Right, if we go. Right, we're not going to do any more of that. Right, so, and we can see, same again, is turn the universal indicator purple, showing that we've formed sodium hydroxide, also showing that sodium hydroxide must be an alkali. Right, the final one that we're going to look at is our potassium. Right, potassium, same as the other two. So we're going to get potassium reacts with water to form potassium hydroxide plus hydrogen. Because that outer shell of electrons on potassium is further away than it was on the sodium, that means that that positive nucleus has less of a hold on the nucleus, on the electron, which means that it should hopefully be more reactive. Right, hopefully I should have gotten. Right, so we'll go. So it goes there, so right, maybe let's try and do a big bit. So it goes, it ignites the hydrogen, and it ignites it, and it burns with a purple flame or a lilac flame. When we go and we cut a big piece of lithium, so as you're moving down the group, it's getting progressively softer. Right, last one. Right, and it reacts a lot quicker because it is more reactive. So that is our